Assalamu alaikum. Today we're going to talk about one of the most important topics in machine learning, which is principal component analysis or PCA. The main task of this is simplifying complexity with dimensionality reduction. So what is this actually PCA is? So actually for this I want to take an example like suppose we have a data set of 100 people where their height, weight, size and also other features are contained. So actually in here some of the features are similar in nature and some of the features are not similar. So what PCA does that is remove the similar features and it only considers the most important features. So here the dimension can be reduced easily. So PCA can reduce the dimension by removing the non-important features. So actually that reduce dimension while retaining variance, find access, maximizing variance, simplify large data sets for easier modeling. Actually, it simplifies a large data set by reducing the complexity, by reducing the dimension. So here, we can understand by better visualization of a picture. Just like that here, you can see that this is a 3D scatter plot of a data set. Here, the data are spread out in 3 dimensions. But here, in this, the data sets are spread out in 2 dimensions. So what happened that the dimension is reduced here. So what is the benefit of this? You will understand later that when the dimensions are reduced, the visualization and analysis in the data gets much more easier. So why we need this PCA? So before understanding this, why we need this PCA, we have to understand what is the issue in high dimension. In high dimension, there are some challenges. Just like the visualization and overfitting can be done here. The overfitting and the visualization are here the matter of concern. But what is the benefit of this PCA? That we can remove redundant features. The features which are redundant, PCA can remove them. Reduce complexity. The complexity can be reduced because the lower the dimension, the lower the complexity. Speed of algorithms. Algorithms can be speedy in lower dimensions. And better visualization. You know that in the lower the dimension, the visualization will be better. So why do we need PCA? We have to understand that. So for this we can also see another figure just like that here. In 1D the data are in series. So in series form data can be visualized and analyzed easily. But when these data are in 2D form, here the visualization and analysis is a little bit complex. But in 3D this is much more complex. So the higher the dimension, the complexity occurs much more or higher complexity occurs. So how does PCA work? So we have already understood what is the PCA and what is the methodology of this PCA. Now we will talk about how the PCA works. So actually, first of all, standardize the data. First we have to standardize the data, then compute the covariance matrix. We have to create a covariance matrix. Then we have to find out the eigenvector and the eigenvalues. Then we have to do the selecting top components. After selecting the top components, we can transform the data now. So we can see it is also in a flowchart or step-by-step methodology here, performing standardization, find out covariance matrix, calculating eigenvector, eigenvalues, figure out which PCA to restore, and also we can, last of all, we can replot the data. So what is the example of PCA? So in scenario, 3D data reduced to 2D before spread across 3 features XYZ after aligned across PCA1 and PCA2. Outcome max variance captured. The max variance will be captured in PCA. So you can see some application of PCA, just like image compression. PCA can be used also in the face recognition, also it can be used in noise reduction, also it can be used in data visualization in 2D or 3D plots. So that's all about the PCA. Thank you everyone.